Here's another example from 9.1 or some notes here. Find the function represented by the series S sub n and its interval of convergence, and S sub n is the sum of from n to infinity of 4 times the quantity x minus 3 over 2 to the n power. So again, let's write down a few terms just to get an idea of what this looks like. So when n is 0, that's going to be 1, so we're just going to have 4. So we could write a sub n. And when n is 0, try a few terms here, 0, 1, 2, 3. So when it's 0, we just have 4. Plus, and then when n is 1, we have 4 times x minus 3 over 2. And when n is 2, we have 4 times, that should be all in parentheses, shouldn't it? Excuse me, like that. X minus 3 all over 2 squared, and when n is 3, we have 4 times x minus 3 all over 2 squared, cubed, excuse me, plus dot dot dot. And I kind of line these up off a little bit off center because those are a little longer terms. So I'll dock this up a little bit here. Pardon me. So this is when n is 0, 1, 2, 3, and when n is n, we've got this term here. All right, so that kind of is what it looks like. And you can see that in each case we multiply the previous term by this factor. So it's easy enough to see that a is going to equal 4. That's our a sub 1, our first term. And then our ratio, our common ratio, is just going to be this factor. It's repeated. All over 2, and I can put a parentheses around it if I want. And we know that this is going to converge. It's a geometric series. It's obviously a geometric series because we have a common ratio. So we know this is going to converge. The interval of convergence would be whenever this is going to be the absolute value of r is less than 1. And in this case, we can multiply both sides of this inequality by 2, and the absolute value 2 is 2, so there's not going to be a problem there. So it's going to be x minus 3 will be less than 2. Oops, sorry. And then that's the same thing as saying that x minus 3 is less than 2 or greater than negative 2. Then I can add 3 all the way across. If I add 3 to this, I get 1 is less than x, which is less than 5. So my interval convergence would be 1 to 5. That's the IOC, the interval of convergence, IOC. And the center, here's 1, here's 5. What's right in the middle? 3. So the center is 3. And look over here, see it's x minus 3, so maybe that's going to start to give you an indication of what the center is. All right? Okay, so let's see what the function would be. So we know that if this is the case, we know that S sub n equals a, or a sub 1, all over 1 minus r. So S sub n will equal a, which is 4, all over 1 minus x minus 3 over 2. So we're going to have a little fun with this. How are we going to deal with this? Well, right now, S sub n is actually a function of x, so I can start to write it as f of x. And since I have a complex fraction, I could right away just, rather than simplify this, which would be kind of a pain, I just multiply the top and the bottom by the least common denominator, which is 2. And that'll start to make things clear up faster, I guess. So it's going to be 8 on the top. And 2 times 2 is, I'm sorry, 2 times 1 is 2. And minus, I still have the parentheses, and 2 times x minus 3 over 2 is just x minus 3. And then I can remove the bottom, parentheses in the bottom to simplify, so I got 2, plus 2, minus x plus 3 And that's going to be 5 minus x. There we go. So 8 all over 5 minus x. And that's only going to hold for the interval convergence, so x has got to be greater than 1 and less than 5. Okay. So for any number in this range, greater than 1 and less than 5, or between 1 and 5 on this interval convergence, then this function can be represented by this series, or vice versa if I work this series out. So if I had a series like this, it might be a little harder to calculate if I wanted to put like 3 in, and put, or not 3, let's say. Well, we could put 3 in, but in case we did, we just get 4. But if we put 3.5 in or 2 in, we would have to work all these out, and we would still end up being a lot easier just to put in here. Okay? And one little note on some of these things. You see a summation like this, 4 to the n, all over 5 to the n plus 1. Is that a geometric series? And what's the common ratio? Well, it might not be easy to see like this. So what you could do is you could rewrite this. We could write this as 4 to the n all over, and this would be 5 to the n times 5. And what I could do is I could take that 1/5 and put it in front, so that's the summation as n equals 0 to infinity of 1/5 times 4 over 5 to the n. Because we got 4 to the n over 5 to the n, so we could combine that. See, 4 to the n over 5 to the n is 4 over 5 to the n, and we could put the 1/5 in front. So once you see something like this and you say, hey, that makes sense, all right? Now it looks like I've got a common ratio of 4/5 because I keep multiplying by 4/5. So in this case, my a sub 1, or my a, as they say, would be 1/5, and r would equal 4 over 5. Okay? Hope that makes sense. So that's 4 over 5 to the n, and then we have a 1/5 in front. So you can see that's a geometric series, so I want to be aware of those little techniques, breaking these up. Okay?